All right, let's get right into it. Stan Gibilisco, Teaching Yourself Electricity and Electronics, the fourth edition specifically. I knew about this book. I knew I had a different version. I had version 3, edition 3, and for me it wasn't as good. This edition, however, is one that I've just been itching to share with you guys because it is so good. Now, I made a post about this earlier. Stan Gibilisco, he is an author for McGraw-Hill, a textbook company. They also do some of these kind of just what I call like personal issues, right? It's like personal editions of text that are academic, but they're not textbooks. This is not a textbook. This is the kind of book that you would use if you wanted to teach yourself electronics. And it is a good one. It is a very good one. So we're going to go through probably the bulk of this book. Of course, time is always a concern, but we want to go through the bulk of this book and really show you what's so beneficial about this. So there's a couple of things. As I said in my post, one thing that's really, really nice about this book is that it covers electronics in a way that is very practical knowledge, very useful knowledge for the builder. It's geared towards the person, again, to teach yourself electronics, someone that wants to design circuits, build and design circuits. But it also has a lot of really good information for those that are actually doing academic studies in electronics. So it is for the builder and for the person that might just be doing academic studies or looking to do academic studies. It's a good primer to get into electronics if you're trying to get a head start in coursework and understanding if you're going into electrical engineering, which I would absolutely recommend. This is something I wanted to touch on earlier, that part of, if you're talking about academic success, part of your success in getting into a degree program that's otherwise, known as difficult or whatever, there's it seems like a lot of later in life learners here. So people are more adept to teaching themselves. But one thing primarily to do is to start learning before you take the classes. Okay, that is something I always do, which again I haven't talked about yet, but that's something I always do. If I'm taking a class, especially something that's not just difficult, but something I actually have an interest in, I'm going to get a couple books on that subject before I even enter the class, before I even start the class. So that kind of gets you warmed up for it. It doesn't mean you have to master it, but it just gets you to get familiar with the knowledge, so it's not the first time you're seeing it when you get into the class. Okay. But another thing I like about this book is not just that it tailors itself to the builder and to the academic, but it also has a bunch of quizzes at the end of each chapter, each subsection. There's a quiz that you can go through, so you can teach yourself and you can see what you remember, do some problems, see what you can figure out yourself, and then also that gets you kind of familiar with the kind of questions that you might want to ask and know about. You see those tests, those little quizzes that he has in there. They're not just we do quizzes all the time in the academic setting. And then sometimes it's well, why is this even on the test? Because I know it's not practical knowledge. That's something I'm having a really big issue with lately when it comes to my academic studies, because I'm noticing how much information sometimes, especially in the electrical engineering courses, are not they're not going to get you any better at building circuits. It's just so deep in theoretical abstraction that I could see why a lot of people are still looking for information outside of academia, because let's say if I only had that kind of information that I've been learning in school and I went to try to build circuits, I wouldn't know half as much as I do or be as comfortable as I am with approaching actually building things, because it's just not tailored in that way. It's tailored in a very theoretical sense. So just like my other videos when I talked about the components and what questions you want to ask and know about with the components, the same kind of approach here is you're going to say, what do you want to know about Ohm's law? That's going to help you build a circuit. What do you want to know about inductors? So, you're going to learn about the relationships, RC networks, and things like that. They're asking certain questions. So let's dive right in here. We're first going to go, of course, into the table of contents and see what the content is for this book. Okay, here's the contents here. So basic physical contents. So of course he goes through atoms, protons, neutrons, isotopes, electrons, which I think he covers all this stuff really well. Compounds, molecules, conductors, insulators, resistors, semiconductors, current. This is just chapter 10 on current. So the first chapter, basic physical concepts, is only 13 pages long. Page 14 there is a quiz. Okay, from current it goes on to static electricity, electrical motive force, that's cool that he covers that, non-electrical energy, and then there's a quiz. And then we have electrical units for chapter 2, which goes into volts, current flow, amperage, resistance in ohms, conductance, and the Siemens, power and the watt, a word about notation, we'll look into that, energy and watt hours, other units of energy, alternate current, hertz, rectification, pulsing direct current, safety considerations, magnetism, magnet units, there's another quiz. Then we have measuring devices, electromagnetic deflection, electrostatic deflection, thermal heat, amp meters, voltmeters, ohm meters, multimeters, FET voltmeters, watt meters, watt hour meters, digital readout meters, frequency counters, other types of meters, and there's a quiz. Direct current circuit basics. Direct current circuit basics. So we have schematic symbols, schematic wiring diagram, volts, current, resistance circuits, Ohm's law, current calculations, voltage calculations, resistance calculations, power calculations. You see how it's just really itemized very well. This is one of the books that's right, one of the reasons why I love about it. It's itemized very well for the new learner to really know what they need, and it's in a great sequence for what they need. Resistance calculations, power calculations, resistance in series, parallel, division of power. That's probably going to be like voltage dividers, series and parallel resistance, direct current analysis, current through series resistance, current through, or voltage across series resistance, voltage across parallel, power distribution, Kirchhoff's first law, Kirchhoff's second law, voltage dividers, there he goes. And there's another quiz. And then resistors, the purpose of a resistor, fixed resistors, potentiometers, the decibel, resistor specifications, cells and batteries, so electrochemical energy, miniature cells, lead acid, photovoltaic, so they go into solar panels, fuel cells, magnetism, geomagnetism, cause and effect, magnetic field strength, electromagnetics, practical magnetism. Then he goes into part 2. Part 2 is like chapter 9, is going to be alternating current. He's going to talk about sine waves, periods, frequency spectrum, why alternating and not direct. That seems like a good conversation to have. We might want to highlight that. Page 155, keep that in the back of our heads. We might want to look at that in depth later on. Inductance. The properties of inductance, practical inductors, the units of inductance, inductance series, parallel, air core, coils, unwanted inductance. That's a really good thing to learn about. 171. As you get into electronics more and more, you'll start, it's kind of like anything else you might assume. This happens in a lot of disciplines. It's like what you learn initially is stuff that's like on the surface, the primary stuff, and then you learn about like the kind of parasitic stuff, the stuff that happens underneath the stuff that you're building that you might have not been concerned about before, because as you get more particular in your circuit designs, or your circuits get more sophisticated or more sensitive, then you want to start to account for like the parasitic parameters that exist within the circuit just by virtue of the circuit being assembled in such a way, or being comprised of certain parts, or being near certain other parts, or being in a certain environment. So you can have parasitic resistance, capacitance, parasitic inductance, right? We talk about these things as components most of the time. Like a capacitor is a component, but capacitance is a unit. It's a phenomenon. Capacitance is a phenomenon. We have resistors, but resistance is also a phenomenon. We have inductors, but inductance is actually a phenomenon, right? So all those phenomena are always lurking in and inside and around your circuit, and between relationships with other items in the circuit. And that is something that you start to delve into a little bit more when you get deeper into it. The art of electronics gets into stuff like that a bit more, which is more advanced material, and that is one of the reasons why I appreciate that book. But yeah, so let's go on. Chapter 11, capacitance, the properties of capacitance, practical capacitors, units of capacitance, capacitors in series, parallel. See, very systematic. He goes through the same kinds of things for every single subject here. Phase, instantaneous values, instantaneous rates of change. It could be, I don't think there's any calculus in this book, but if they're talking about instantaneous rates of change, there could be some implications there. Vector diagrams. This is kind of the stuff, and this is what I mean about the applicability of this book to people that are electrical engineering. This chapter 12, phase, where you're talking about vector diagrams, expression of phase difference, circles and vectors. This all that kind of stuff would very much be, this whole chapter 12 very much would be for someone going into electrical engineering, not necessarily someone who's just wanting to build circuits. Inductive reactance, okay. Another interesting subject, probably a little bit deeper for the most part than most people need for just building circuits, unless you're doing stuff that involves a lot of coils and a lot of inductance, and you're more into maybe power electronics or electricity, and not electronics itself. Capacitive reactance. If you want to learn about touchscreens, that's a principle that's going to be very applicable to that. But again, these kind of chapters, chapter 14 again, are going to be more applicable to the electrical engineer student. Impedance and admittance. Imaginary numbers, complex numbers. Conductance. Admittance. GB plane. Again, another chapter. I would say it's more tailored towards electrical engineering students. Then we have circuit analysis. RLC. If you see RLC, that means that you're going to do circuit analysis with inductors as well. Probably another chapter again that I would say is probably more tailored towards the engineering student, or someone who just wants to get more familiar with getting deeper into electronics. Power and resonance and alternating current circuits. That's more power electronics, but again, more electrical engineering based. Great knowledge. Then we have transformers, impedance matching. That would be great for the builder to know about. Now he has part 3, basic electronics. So he's probably going to get into there more of the stuff that. So that was alternating current. Alternating current, that has more of the power electronic stuff and some of the theoretical things that would be more applicable to electrical engineering students. Then we have basic electronics. Well, this portion of the book, part 3, chapter 19, is going to be probably where all your bread and butter is for people that want to build. So we have introduction to semiconductors, semiconductor revolution, materials, doping, charges, all that, how diodes are used. See, again, not just what diodes are, but how they're used as voltage regulation, amplitude limits, frequency control, signal mixing, switching, frequency multiplication, detection, rectification, oscillation, energy emission, photosensitive diodes, power supplies. We're going to learn about how to build some power supplies. I recommended in my last video, you guys want to learn electronics, start building some power supplies. We'll build some power supplies pretty soon here. I'll start mapping out a power supply. Like I talked about, if you want a bench power supply, we can come up with some ideas for some bench power supplies. So power supply section has everything you probably would expect. So power transformers, rectifier diodes, half wave circuits, full wave center tap, full wave bridge. There's a difference between those. This is what I want to get into. I'll probably do an in-depth video on just chapter 1 here, or chapter 21, so we can talk about this, because that is it's going to be very important with building your power supplies. Then chapter 22, bipolar transistors, common emitter, common collector circuits, biasing amplifiers, gain versus frequency. Then field effect transistors, so we're going to Jeffs and MOSFETs. Then we have amplifiers. 24 is going to be amplifiers and oscillators. This is when you're going to start getting a lot of circuitry knowledge. Wireless transmitters, receivers, very good information if people want to go that route. There's information about transmission media, wave propagation, detectors, audio stages, television reception, digital basics, numbering system logic, digital circuits, binary, digital communication, antennas, integrated circuits, electron tubes. So they actually have a chapter on tubes, which I think is pretty cool, chapter 29. Transducers, sensors, location, navigation, acoustics, audio, high fidelity, personal and hobby wireless, so cellular communications, satellite networks, amateur radio, shortwave, computer and internet primer. So it talks about some computer devices, monitoring, robots, artificial intelligence. That might be some interest to some of you guys. And there's a final exam in here, actually, which is pretty cool. And there's a answer key for all this. Let's see what he prefaces his book with, to see what he has to say. So this book is for people who want to learn the fundamentals of electricity, electronics, and related fields without taking a formal course. This book can also serve as a classroom text. Okay, very important. Exactly what I've noticed about this book is that it's not just for builders. It could also be served really well. I mean, it's got college level material in here. College level material in this. So like you said, if you weren't even in high school or something and you were learning this stuff, you'd be really well primed. This edition contains new materials on transducers, sensors, antennas, monitoring, security, and navigation. Materials from the previous edition have been updated where appropriate. As you take this course, you'll encounter hundreds of quiz, test, and exam questions that can help you measure your progress, and that's what it's about. This is not, again, it's like I said, this is why it's so great. Like, this is like a test or quiz that you'd want to take, because it's not one that's just like, oh, do this for a grade, or you're just doing it. No, this is all about seeing where your knowledge is at, and seeing where it's rusty, and seeing where you need work, and really finding out. The questions that he asks here, and we're going to go over some of them. The questions that he asks are things that are really pertinent to things that you'd want to know to build. They are written like the questions found in standard tests used in educational institutions. There is a short multiple choice quiz for every chapter. The quizzes are open book. You can refer to the chapters in the text. Chapters in the text when you're taking them. When you have finished a chapter, take the quiz, write the answers down, and give a list of the answers to a friend. Have your friend tell you the source. Tell you your score, but not which question you got wrong, because you're allowed to look at the text when you're taking the quiz. Some questions are rather difficult. At the end of the section, there are multiple choice tests. These tests are easier than the chapter quizzes. Don't look back at the text when you're taking the quizzes. A satisfactory score is at least 3/4 of the answers correct. You will find a final exam at the end of this course. As the section ending test, the questions are not as difficult as those in the chapter ending quizzes. Don't refer back to the text when taking the final exam. A satisfactory score would be at least 3/4 correct. The answers to all the multiple choice quizzes, tests, and exams questions are listed in the appendix in the back of the book. You don't need, let's listen to this one. A lot of this is going to make you guys happy. You don't need a mathematical or scientific background for this course. Middle school algebra, geometry, and physics will suffice. There's no calculus here. I recommend that you complete one chapter a week. That way, in a few months, you'll finish the course. You can then use this book with its comprehensive index as a permanent reference. And that's what you want. And that's why I love Stan, and that's why I love this book, because this is an evergreen book. As so far as the field of electronics will exist, this book will be pertinent. Suggestions for further additions are welcome. And exactly, and this is something I've touched on, I think, in other videos too. Again, I love math. I'm a math teacher. I still take math courses, but I want to let you guys know and understand that you don't need high-level complex math just to do electronics. And in a lot of ways, it depends. It depends. But I mean, if you're just going to build something, just build something. You guys right now just need to really just learn how to put circuits together. And once you learn how to put circuits together and build your circuits, then you can refine them, and you can get more mathematical. The math helps you in engineering fields, writ large. What the math helps you do is to really sequester, any kind of mistakes, and get all that figured out beforehand. In a lot of ways, really to save time and cost, right? Because if you're just tooling around and wanting to build something in this environment where you're just teaching yourself, or you're just building something for yourself, it's not, time and money necessarily aren't the concerns if you're just doing this in your leisure. But again, in engineering, time and money are like the two most important things. So to save time and money, we tend to be pretty intense with the calculations so we can save time and money in engineering. But in this case, time and money shouldn't be an issue. When it does become an issue, I mean, just like myself, that's one of the reasons why I say all the time, it's like some people are like, hey, let's build something. And I'm like, well, I don't build very much. I don't really, for one reason, there's not a lot of things I need, but I usually build towards a purpose. If I need something, then I'll build it. But then at the same time, I need time. It takes time and money to build things, and time especially is something that I don't have very much of. So it behooves a person like me to be more calculated about what I'm going to build if and when I'm going to build it. And that's more of what I spend my time on. To be honest, it's not that I never build things, it's just that I'm very far away in a lot of ways from just building the actual product or just tooling around with the actual physical stuff. But there's tons of designs and things that I still work on. There's things I'm planning for the future, but that has to do with kind of, the point that you're at in your journey and how much and how involved you're trying to be. I've come from making products before, and now I'm more building educational institutions around my products. So the products are almost secondary. It's more education for me is more primary, and then the products are secondary. But it could be the reverse for you, or education could not be the thing. It could be you just want to learn, or you just want to build stuff, or you want to make stuff, and you want to manufacture them at a small scale. I intend to get into some small scale manufacturing in the future as well. This is why I still design things, and and it's also, again, different. If you're trying to build a company, it's different than just building a product. I built products before, but now I'm more focused on building a company. If you're building a company, then you have a suite of products and projects that you work on, and for that, again, a lot of calculation, a lot of time, a lot of planning, because it's not just. And this is not the unfortunate part, but you'll see again if you get to that point in what you're doing here is that. The circuitry and all this stuff, this is why I like to do this with you guys, to still stay involved in it, because all that stuff is it becomes tertiary. When you're getting into engineering as a company, and you're trying to grow something bigger, something that has multiple projects or products, then it's mostly about time, efficiency, capital, how to save money, how to do things, manufacturing processes. That's like a big thing I spend my time on, is manufacturing processes. How am I going to manufacture? How can I do the things I want to do in the spaces that I want to do them in? And how do I make it financially viable? How do you make it economically viable, to produce in the space that you have? Or if you had to rent a space, or if you wanted to get a shop. It doesn't matter if you're doing this, here I do this on my property at my farm. But it doesn't matter if you're doing this, into rented space, a shop, or you're doing it in, 100,000 square foot, warehouse. All these things are still applicable. What your business is going to live and die by, as a engineering business, is going to be. It's going to be the time, money, and efficiency, which is all stuff that you have to take care of and plan on the back end. It's not. Unfortunately, it's not all the stuff that we like to talk about here, But again, this is why I love doing this. It gives me an opportunity to still, stay relevant with the circuitry and the stuff, because for me, I love the design process, But that's not the only thing it takes to get things off the ground. So we can go through a little bit of this. I'm not going to spend that much time on, I don't think, the first chapter. This is the basic concepts. Like atoms and protons. You can look at the book that you see. It has a chapter or a paragraph or two for each topic that he talks about. He's a really straightforward, I think, simple writer, which is what I like about him. He has some good illustrations in here too. I don't find this book very intimidating. I find it very approachable. Then we have a first quiz section. Then we go to electrical units, so we talk about volts, amps, and he goes into resistors. Alternating current in hertz. Instantaneous voltage. Safety considerations. And then we have a little quiz here. We might have to make some videos on these quizzes. I think that'll really, we can walk through some of these quizzes together, and that could really prime you guys for some knowledge. I definitely I need to get a physical copy of this book. I'll see if I can get a physical copy of this book, because it's a great one to have. So we're going into amp meters. You see in this book, page 45, we're already into meters. So again, it's very educational. It's really practical knowledge. It's not, he's not going to spend, 30 pages talking about one thing in here. Oscilloscopes, bar graph meters, and we have a quiz. Direct current basics. We have some. I love the symbology that he has on here. It's nice and large. It's very practical, like stuff that you would see. The very common symbology. Sometimes people put symbols in here that aren't used very much. Current calculations. Again, like he said, this is all algebra, basic algebra stuff. Resistance and parallel. We don't have to get into any calculus or anything. And like I said, you shouldn't have to with the stuff that most of the things that you're trying to build. There's another quiz. Direct current circuit analysis. This will be interesting. Definitely something that you guys want to spend some time on if you're trying to get an understanding of circuits, and if you're struggling with an understanding of circuits as well. Looks like he's starting to get into a little bit of Kirchhoff's law here. There you go. Kirchhoff's law. It has appeared. Another quiz. In that section especially, again, this is something that would be a section I would earmark if I was going into electrical engineering as an undergrad. I would definitely mark the Kirchhoff's law section, the circuit analysis. That's going to help you out tremendously if you get an edge on that. Resistors. Potentiometers. Very good depiction of the wiper here and how a potentiometer works. And then I guess he's showing you kind of the a rheostat too, and showing you how it's graphed. An audio taper, so that gives you a kind of good indication on how these things work. Because not all potentiometers are linear. You have logarithmic potentiometers as well. Decibels. Tolerance, power rating, temperature, compensation, resistor color codes. Here's a test. Cells and batteries. If I'm moving fast, it's because I want to, again, I'm trying not to make this video too long, and I want to get into the circuits most of all for you guys to see. Magnetism. Here's test 1. Part 2 is alternating current. We'll probably go through this pretty quick because again, I want to get to the circuits. Sine waves, or square waves, sawtooth waves. Complex irregular waveforms. root mean square. So RMS voltage, she covers that, which is an important topic. Why alternating current and not direct? I think that's a very important topic. Oops. Can I go back to that? Let's see. Why alternating current and not direct? There's a quiz after that. I think we'll cover that in more detail later on. Inductance. If you want to learn the electromagnetics and then inductance, that would be a good way to do that too. Capacitors. What is this? Phase. Maybe look at this a little bit. That's more for the electrical engineering student, I would say. But if you want to really have a in-depth knowledge, then that would be good. Next is inductive reactance. Again, a lot of this AC theory is much more for electrical engineering or electricity, if you want to get into power. Let's get into the circuit stuff here. Imaginary numbers. Definitely more electrical engineering based. Again, excuse me if I'm going faster, but I know a lot of people in here aren't as concerned with that, but they're more concerned with building circuitry. And I want to show you that there's some pretty good diagrams here. There's more complex numbers. This doesn't mean that this stuff isn't useful. It's just, again, I try to cater to a wide variety of audiences, and I love to do this kind of stuff. But again, I don't know, some people find it a little bit, the minutia kind of, boring or whatever. So we'll continue. Come on, where are we? Getting close to part now. Transformers and impedance matching, that was something, I wouldn't consider that necessarily for the electrical engineering student. I would say that's good for the builder too. Of course, depending on what you're building, you might not encounter that so much. In audio electronics, that's a big topic. Test 2, so now we should be getting into the circuits after this test. Let's see. Okay, basic electronics, part 3. So, intro to semiconductors, the semiconductor revolution, semiconductor materials, doping and charges. I think that's a pretty cool topic to talk about. It has to do with the holes and electrons and how they flow through the PN and PNP, the PN junctions. Yes, again, really good illustrations of that. How diodes are used. Again, so really good purpose-driven information. Diodes are probably, let's say if you're just getting started or you've been with me for a little bit and you're still trying to grasp electronics and semiconductors and how to build circuits, let's say you could start on this chapter and how diodes work. That would give you a good start. So here he talks about the half-wave rectifier. Then he shows a detector circuit for a radio, like a crystal radio set. Then frequency multiplication, switching, voltage regulation, amplifier limiting. So he's showing you how diodes can clip a signal. So you have a signal here that used to be a sine wave, but now you can turn a sine wave basically into a square wave with diodes. Some more quizzes. Power supplies. Great topic, good illustrations. So we have the half wave rectifier, okay? Then we have a full wave rectifier with a center tap. And then we have a full bridge rectifier, okay? Very good things to know about. I think we'll go over that. We'll go over that sooner than later, I would say, because we need to build a power supply, and that's a really good way to start, because again, if you're doing electronics, you'll need power. I know some of you guys might be doing digital stuff and only need 5 volts, and this might be easy to find 5 volts or a 5 volt power supply, but it's really cool to build one too for yourselves. And especially if you could set yourself up with something that had a 5 volt fixed, maybe like a 30 volt variable or higher, because we could be dealing with higher things that need higher power eventually. He goes into a voltage doubler. He gets into filtering, voltage regulation, protecting equipment. I think this is probably where we're going to start. And it's funny, when I got at the tail end of when I was really focused on electronics, power supplies really became of interest to me, because I saw just how important they were, with your circuit, especially in audio electronics, because it began to realize that if you didn't have a good power supply, then you wouldn't have a good amplifier, a good product. There's a lot of things that you could do with your power supply to really to make your audio circuits sound better. Okay, so bipolar transistors. I'll be showing you the inner working of a transistor. If you want to know what a transistor looks like internally, that's the basic idea. It's just 2 opposing diodes. Biasing and amplification. This is really good. So again, I think this is really where we're going to start. We might use this book as an educational resource and really delve into the common emitter amplifier, textbook example of a common emitter amplifier. Common emitter amplifier, but now it's using the emitter as the input and the collector as the output. Common collector. This is just a really good basis for us. The field effect transistor. If you're getting a little bit more sophisticated, it might be more, the field effect transistor might be more value to you. You're getting more sophisticated, or you're getting into power circuits with the MOSFETs especially. Amplifier oscillators. Again, this is something I want to talk to you guys about. I've said this in other videos as well. What's going to dictate, figure out what you're going to make more progress if you figure out what you want to do early on. So figure out the subject, the subcategory of electronics that you really want to focus on, something that you really want to build or have knowledge of, and focus on that. And approach something like this text in that way. So he gets into power amplifiers, just really cool stuff, like Class B, push-pull amplifier. You have some transformer coupling amplifiers, RF circuits. Oscillators and stability, audio oscillators, multivibrators, wireless transmission. This might be interesting. I don't know if anyone in here is interested in this kind of thing, but it could be entertaining. Pulse modulation, I think that's very valuable to know about, because just the way technology works today, in particular power supplies. Again, going kind of fast. My apologies. I'm just trying to get through this. we will definitely cover a lot of this book in more detail. I think the next video where we'll do a section on the power supplies, because that'll help us actually build one, and that'll help us get on the same page. So I'm just not talking about things that people aren't aware of. Digital basics, logic, color, another test. Okay, test 3. And he calls this a course because it is. I mean, like I said, you'd be really well prepared. You would excel in your studies if you had to, if you did this and then went into a college course. Antennas. I probably wouldn't spend any time on that, but if you were interested in something like that, then, have at it. Integrated circuits. I would go from the semiconductor section, the transistor section, into integrated circuits. I don't know why he has them so far apart. I would say that's a little bit of a flaw there. He had a lot of things in between that weren't as applicable. But integrated circuits go right into, diodes. Diodes are the parent of transistors, and transistors are the parent of integrated circuits. So makes sense to have them all next to each other. Then the electron tube. We turn tubes, vacuum tubes in here, which I think is pretty cool. It's paying homage to the vacuum tube. Transistor sensors, location and navigation. Again, if you're building anything that you want some kind of detection device, or you want to do some kind of measurement or something that has to do with location, approximation, accelerometers, and things of that nature, then this chapter would be useful for you. I know people getting into microcontrollers tend to be interested in stuff like that. Acoustics, audio, high fidelity, definitely something I'm into right here. But again, if you're not, then not a big deal. But this is what I like about it. It's not, see, as you can see, there's some theoretical stuff in here, useful theoretical, very applied theoretical stuff, but then you have information about, I call it like the exterior of the circuit. Like, this is not about the circuit. He's not talking about audio circuits. He's talking about the parameters of audio, like waveforms, path effects, decibels, acoustics, phase in acoustics, linearity, dynamic range, right? Because he's talking about the more experiential, manifestation of what you're going to build, which is very useful, which a lot of books don't do, Nearing the end here, personal and hobby wireless. Kind of interested to see what he's talking about here. Computers and cellular. Looks like maybe just some simple block low Earth orbit satellites. I guess he's just showing. He's not telling you how to build one. I guess he's just explaining. Amateur radio. It kind of gives you some block diagrams of how these things function, which is insightful. It's nice to learn how things work. Internet primer, hard drive. And if someone's more into computer technology, he has some things in here for that. Scanners. Again, just more basic, maybe more explanations about these things than anything. About how the general operation of these things. Robot generation laws. Oh, robot arms. So he gets into a little bit of robotics here, which is interesting. Oh, he gets into AI a little bit here too. Artificial intelligence. Then test 4. I think the book's coming to a close soon here. There's the final exam. All multiple choice questions. So we're going to use this book, and here's all the answers here in the appendix. We're going to use this book, and I think we're going to start on the power. And this is what I left to this. He has a really good. I wanted to show this is what I was kind of wanting to get to before the end of this video. These schematic symbols in here are just immaculate. If you're still learning schematic symbols and want a resource for schematic symbols, this would be the best resource right here. Hands down. Just really good symbols. And he has pretty much all of them. You know, a pretty exhaustive list of the most pertinent symbols that you're going to see and use and run into. So kudos to him for doing that. And the illustrations here are just great. Switches, some diodes, transformers, showing you all kind of different transformers. Just great. Transistors. I mean, absolutely study this. Even has all the tubes, the pentodes, and everything like that. Definitely study this if you are interested in, even just wires. Look at this. Okay. So showing when wires are connected and when they're not. That's a jump right there. Some suggested additional reading. Starting in electronics. That's the Oxford Press. Electronic circuits for the evil genius. That sounds interesting. Electricity Demystified, Electronics Demystified. These are 2 books by Stan here. Let's see, Basic Electronics Theory with Projects and Experiments. Personal Computing Demystified, Electronics for Dummies. I don't have a dummies book on electronics. I don't know. Practical Electronics for Inventors. We talked about that. We know of that. I believe that's the same book. Yeah, that's the same. The Audiophiles Project source book. I have a copy of that. I think it's a later version, but I have a copy of that. If anyone's interested in audio electronics, then I definitely cover that in more detail. Then he has a robotics demystified one here. So, I think that is it. Again, that's Stan Gibilisco's Teaching Yourself Electricity and Electronics. I do believe that we will return to this book very many times. I think that we will probably have a video series on this book and those chapters, because for those that are learning, I wouldn't mind to walk through some of this stuff with you guys and really, get through the knowledge and starting to build our knowledge and repertoire and understanding of electronics through this book, because as far as any of the ones I've reviewed with you all, this would be the best. This is one, I would have loved, this would have been a keepsake when I was younger, starting electronics. And like you said, this is definitely an evergreen book. It's definitely something you can rely on, and it's something that's encouraging you to really learn and go through the process. So that's what we'll do, and we'll start with the power section, and we'll go forth from there. I appreciate you guys for watching. I'll see you soon.